Good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 46 should come up as soon as you log in. Let's get started, please. How's everybody doing? Good? How was home play? Very good. Let's go. I saw some of you rushing home yesterday to do your home play. Let's go. All right, this session is being recorded. Just giving you a heads up, so stay focused. Bye. All right, let's get the show on the road. Of course, you use the shortcut formula, which means we need the sum of all data, or sum of x. So what'd you get for that sum? Let's see, let's go with Amelia. What'd you get for the sum of x? 200. Hands if you got that. That is correct. And from there we go to the sum of the same data, but squared. Sum of the data squared. Share with your neighbor, and then Amelia's going to pass someone. Data squared, sum. All right, pass someone, Amelia. Who? Logan, what you get? $13,598. Hands if you got that. Looks about right. 598. Of course, you substitute that in the formula, and we know that n is what, everyone? N is 4. Okay. Therefore, see what I did there? Therefore. Right. Standard deviation. Share with me where you got standard deviation. Then Logan's going to pass it to someone. All right, Logan, pass someone. Brandon. 11.90. 90 what? What? Standard deviation? 1,000 what? 1,199 for standard deviation. Hands if you got that. I sense a disturbance in the force. Oh, you got some of that? Yeah. Looks about right. So what'd you get for variance squared? Brandon Doherty. Okay, and I pass it to Brandon Doherty. What'd you get for the variance? Which means the number before you square root to get the standard deviation. $34. What? What are you guys talking about? 34.63 for the variance. So if you take the square root of this, oh my goodness, bah. Come on, people. So what you're saying that the variance is 1199? 1,199? All right, let me go over this because somehow you guys are giving me different numbers. All right, so variance. We get n times the sum of x squared minus the sum of x squared over n minus, n times n minus 1. Okay, so variance, we got 4 times And then we got 13,598. And then we got 200. And then we got 4 times 3, because n minus 1 is 3. So therefore we end up with variance equals 4 times 13 minus 598 minus 400, my bad, 40,000, is that correct? Yes? Over 12. So calculators calculate, what is 4 times 13,598? 54,000 what? 392 minus 40,000 over 12. So that gives me 14,392 divided by 12, and that gives me, thank you, sir, 11 and 99. Point what? 0.3 approximately. All right. So that's the variance. That's the what? My goodness. By now we should know the difference between the variance and the standard deviation, people. Yes, sir. He's out. Yeah. All right, so standard deviation, just the S by itself. We take the square root of 1,199.3, and that gives us, Brandon Doherty, 34.63. Hands, have you got that? Woo! Oh my goodness. All right, send that in, please. And copy the agenda. Warm-up number 46, measures of variations. We're still with the group data. Hopefully your home plate was pretty straightforward, yes? Yes, Mr. Q. All right, good. And tonight's home plate, page 144, number 17, 19, 20, and 21. Only. All right, last night's home play, here's the code for the access to your home play, WQ9K3. Write that down, WQ9K3. WQ9K3. Okay, we good? How about now? Yes. Say it again. The agenda to your screen? Yeah. All right. So last night's home play were these two problems. Go to Canvas, turn them in. And just because I'm nice, I'm counting that as a pop parte. Let's go. Turn that in, please. Tonight's home play looks like this. Ooh-wee. Let's go. All right, get a Cornell note. I'll give you guys some time to turn in your home play and get a Cornell note ready. Copy and go. All right, thank you for turning that in. Here we go. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. Now, by now, we should be experts at all this. You wake up and you're like, oh, standard deviation, right? All right. You get home and then they ask you to clean your room and you're like, variance. All right? Clean your room. All right, we got that. So, turn to your neighbor, remind them of a definition in your own words of measures of variation. Remind your neighbor, please. All right, type it on your screen, 30 seconds. Type that on your screen. Type it on your screen. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, here's one from one of your colleagues. They wrote, commonly measures of variance to describe the spread of data, or how the data spread. I'll take that. All right, thank you. Next, on your screen, you don't have to share this one with your neighbor. Fill in the screen. You got about 40 seconds. Fill in the screen. You should know these by now. Go back to this one. All right. So, formulas. Go back to your notebook and make sure you have all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 formulas with their proper names. So double check, please. 16 formulas. Because like I mentioned, before the end of this course, we're going to have close to 30 some formulas. All right. Double check your work. Let me send that to your screen. Check your formulas. Fill in whatever you don't have. I'll give you some time. Go. Pretty good, yes? All right, so your formulas are there. We got this. So quick recap from yesterday. Look up to the screen. Yesterday, we started with a distribution, a group distribution like this. In other words, tell your neighbor what I mean by group distribution. Tell your neighbor what I mean. What do I mean by group distribution? Mario. One word. Table. That is correct. I give you guys a table. From there we built different columns. Is that correct? Like so. And then we were given a formula, new formula with a midpoint squared. Once we substitute values, we compute, and we end up with our variance and standard deviation. So far so good, yes? That was last night's home play. All right. So, from there, in class, I said, but what if I don't give you a group distribution, I just give you raw data? What do we need to do? Well, Mr. Q, we need to find how many classes, and we chose 5. We need to find the range, we need to find the width, and start our group distribution. Is that correct? All right, and that was part of last night's home play. All right, so do me a favor, get your formulas in front of you, because I want to see how well you know your formulas. Oh yeah, here we go. Don't copy this problem, let me read it to you. Look up, please. It reads, the data represents the record high temperatures in degrees Fahrenheit for each of the 50 states. Construct a group frequency distribution for the data using 7 classes. So think about it. Construct a group frequency. Are they asking us to do anything else? No, just to construct a group frequency. Tell your neighbor what that means. What does that mean? What does that mean, Brandon Darty? Construct a what? A table. That is correct. So, talk it over your neighbor. Let them know. Look at your formulas on your page of formulas. What formulas do we need to construct that group distribution? Talk to your neighbor. What formulas do we need? And hint, hint, wink, wink, they are 3 formulas. What 3 formulas do we need to construct our group distribution? All right, let's see. Get us started. Alessandra, give us one. Range is correct. Hands if you got range. All right. So before I ask the rest of them, write it on your screen. What other 2 are we needing? We got range already. Give us another one, please, Aaron. Width, that's the second one. That is correct. So we got range, width. We're missing one more for that extra column. Remember the extra column at the end? Yes? What formula do we use? Carter. Mid-range, that is correct. That's the one we use to get the midpoint. All right? From 1 to 5, how comfortable are you so far with that? Yeah, we got this, right? All right? Go to the next one. And it reads, let me send that to your screen. Time spent in rush hour. A sample, my bad, let me read it again. A sample of 12 drivers shows the time they spent in minutes stopped in rush hour traffic on a specific snowy day last winter. Yeah, we don't see that here in the valley. We should have changed that to on a specific hot day in the valley, right? Find the range, variance, and standard deviation of the data. So look at your formulas, talk it with your neighbor, let them know the name of the formulas that we need for that one. Hint, we need 3 formulas. 3 formulas. Talk it with your neighbor. All right, type it on your screen. What 3 formulas do you think we need for that one? All right. As they are finishing typing in, give us the first one. How about Araceli? What would be our first one? Sample variance, okay. So sample variance, so S squared, that's one of them. All right. Hands, have you got that? Yes. How about another one? Pass them one, Araceli. Mia, another one. Range. But what kind of range? Sample range, that is correct. And what symbol do we use? X bar, that is correct. That formula for that one. All right, not bad, which is the sum of all x's, yes, divided by n, low cap n, okay. And last one, pass them one, Mia. What is our last formula? Dayali. And it got quiet right on time, right? We got range, we got variance, sample standard deviation. That is correct. Sample standard deviation. All right, thank you for sending that in. From 1 to 5, how comfortable are you with that so far? Okay, not bad. Good identification. Let's go to the next one. And it reads, this frequency distribution shows the number of pounds of each snack food eaten during the Super Bowl. Construct a pie graph for the data. Think about that one. A pie graph. Now, hint, for this one, you need two formulas. Talk it over to your neighbor, look at your formulas, and type it on your screen as soon as you're done talking to your neighbor. What two formulas are needed for a pie graph? What formulas? Record this. Of course, Aleshka's got it, and Quirin got it. Well, let's start off with Lulu. What would be our first formula? Percent. That is correct. That's one formula. Okay, not bad. And our second formula. Pass it to someone, Lulu. Brandon Doherty. Second formula. Degree. That is correct. Those two formulas are for pie charts. We good? From 1 to 5, comfortable with that so far? All right, we got it. Make sure you send that in. Let's go to our next one. And it reads, automotive fuel efficiency. 30 automobiles were tested for fuel efficiency in miles per gallon. Does it say all the automobiles? Does it say all of them? Just 30. Okay. This frequency distribution was obtained. Find the variance and standard deviation of the data. Look at your formulas. Look how the data is presented. And tell your neighbor which formulas do we use for that one. Which formulas do we use for that one? All right, type it on the screen. Which formulas are needed for that one? It looks like Max got this one. Let's go, Max. Let's go. Which formulas? And hint, hint, you need two formulas. Let's see. I mean, technically you need three formulas, but the two obvious ones that are there in the words that are mentioned on the problem. But we need one small formula for that extra column. Remember that? Yes? The extra column, yeah. All right. Hurry up, hurry up, hurry up. Type it up. Send it in. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, give us one formula for that one. Let's go with, what have we picked in a while? Who? Brandon Doherty. Give us one. Mid-range, that is correct, because we need that extra column for the what? For the midpoint, yes? All right, that's one. What would be another one? Max. The shortcut for what? Sample. Sample what? Variance. That is correct. What? Let's go, Max. Yes? However, we still need a couple more words. Shortcut, sample, variance. For what? What is this called? Tell your neighbor, what is this called? Grouped data. Right? Sample, shortcut, group data, formula for the variance. Yes? And our last formula. Pass them on, Max. Who? Mario. Last one. So we got the mid-range, we got the variance, and we need one more. Standard deviation for grouped data. Look at your formulas. These should be the last two. Is that correct? This is what you did last night, by the way. All right, make sure you send that in. Let's go to the next one. This is the last one of these, just to make sure we got it. It says, using the following frequency distribution, find the mean of the data represented in number of miles running during 1 week for a sample of 20 runners. Talk it over to your neighbor. What one formula do we need for this one? What one formula do we need for that one? Talk it over to your neighbor. After you're done, type it on the screen. Go. 8, 7, 6, 5, 4, 3, 2, 1. Here goes one from one of your colleagues. Correct answer is sample mean. Hands, have you got that? Yeah, that is correct. Why sample? Because it says it here. Sample. And what are they asking for? The mean, that's all. They're not asking for standard deviation or variance or anything like that. All right? So, with that said, tonight's home play looks like this. 17, 19, 20, and 21. So, since I'm very nice, we're going to do 17 here. You should be able to finish in class. And then if you finish that one in class, just pick one of the other three for home. However, if you do not finish this one in class, you're going to do all 4 of them at home. So, I'll leave that up there. For those of you following on YouTube, make sure you put in your practice for all of these. Enjoy. See you guys later. Peace.